Hey everybody, I'm Jay Marshall with NeuroMagic. Today I'm joined by Eric Corman, one of the co-founders of Striveworks, another great startup that we've partnered with earlier on this year. Thanks for joining me today, Eric.
Yeah, thanks for having me.
So, NeuroMagic, we talk a lot lately about what we call kind of the three Fs. So fast, frictionless, flexible. And for us, we're usually talking very specifically about optimizing models and then running those models in a very efficient way on regular CPU architectures. I know for you all at Striveworks and Chariot specifically, you're kind of doing those same value props, but extending it across the entire life cycle. So why don't you take a second and maybe tell our audience here a little bit more about what you all do at Striveworks?
Yeah, sure. So our core offering is Chariot, which is a end-to-end MLOps platform, and it's especially well suited for deep learning. So think tasks in computer vision like object detection or image classification, and also natural language processing tasks. And it takes you in a very low code, no code way through the whole model development lifecycle, from getting data into the system, centrally stored and versioned, to getting annotated for supervised training tasks, to training models on that data, to then cataloging, deploying, monitoring, and refining those models. And so with a very strong emphasis on your second F of friction, and making that, to us, frictionless is the idea of kind of disappearing MLOps, and all that infrastructure piece is kind of, under the hood, and data scientists don't need to worry about, setting up device drivers and getting their libraries in order. They can just, in a very declarative way, say how they want to train something in terms of, model architecture, data sets, and that kicks off this whole sort of process as code.
Yeah, and I love that process as code term. I know for myself, my background, kind of enterprise architecture, cloud architectures with some of the mega cloud providers, that whole kind of explosion in the 2010s around infrastructure as code, and obviously CI/CD and DevOps. I love that disappear MLOps tagline. Why don't you maybe share some of those specific challenges or even examples that you've seen with folks in terms of helping that happen? Because that sounds like that'd be really exciting for folks in this space, especially right now.
Yeah, definitely. And it's definitely had a lot of, engineering challenges on our side to make this happen, make this disappearance happen. And, one of the biggest issues is actually resource management. So one of the benefits of our platform is the diverse amount of environments it can be deployed to. So yeah, we deploy to the, major cloud providers, but we also can deploy on-prem, and we have a lot of customers that are interested in that because, their data is sensitive, for example. And so there, you're dealing with a very finite number of resources. And so an easy way to have MLOps not be disappeared, be very apparent, is if, your model can't train because there's no GPUs available, right? And so, what's key for us in this partnership is that we can offload all of model inferences to CPU, which NeuroMagic software allows us to do. Then we can reserve GPUs for things, just training mostly. And so that, really efficient use of resources really helps in the disappearing of MLOps.
No, and again, is also why we were looking forward to doing kind of this short but sweet video, because I think a lot of times when we talk about getting the performance that we get on CPUs, it's really not about not having GPUs, but it is, again, that flexibility and the ability, whether you're on the public cloud, in your private data center, as you say, at the edge, that anywhere where there's x86 or ARM compute, you can squeeze that performance out and get to run it. And so love the fact that you're automating, again, the rest of that stack. Maybe you give a quick example of what that end-to-end looks like. So, we have these optimized models that we do here in NeuroMagic and offer up in what we call our sparse zoo. Maybe how does that kind of show itself up in Striveworks? Maybe how does that work?
Yeah, so the standard process of training a model in a way that can be deployed by NeuroMagic software, it begins with, in a very declarative way, the data scientist just saying, what they want to happen. So there's a drop down, they select what architecture to use. These are all architectures available through your guys' sparse ML library. So starting with something that's sparse and then training in a way to preserve the sparsity. And then the data scientist, selects their hyperparameters, what's the batch size they want, what optimizer, sampling strategy, data set, obviously, to train on, and so forth. and then clicking, go start, that starts the whole process. And so the system will go see what available compute there is to run the training job, go ahead, train that model, metrics, live training loss, things like that are reported back to the user so they can monitor the progress of the training process. And then once the data scientist is satisfied, with the model checkpoint, they can elevate that to Chariot's model catalog. And so that's now usable as an inference endpoint where you can just post data to. And the main mechanism we look to deploy that through is through neural magic, namely the deep sparse runtime. So that'll be deployed on CPUs without having to sacrifice any inference speed.
So I know we're going to be doing a lot of this stuff over the next upcoming months and quarters. I know for both of us, we're doing things as it pertains to edge device compute. Obviously, LLMs are all the rage. So looking forward to doing a lot more work together in the upcoming months and quarters.
Yeah, likewise.
Thanks so much again for joining us again today. Reach out to us at neuralmagic.com or striveworks.com to keep up with everything we're doing together. Thanks so much.